In geometry, after we talked about the fact that the circumference of a circle was pi times diameter, or 2 times pi times radius, we started talking about, what if I only wanted to find a part of the circumference? We called it an arc length. So if I wanted to find just the length from A to B, in order to do this, I needed to know a couple pieces of information, like I needed to know the angle between those two radii, and I needed to know the length of the radius. So what you would do is you would start by finding the circumference. So the circumference would be 2 times pi times the radius. But then we only wanted a fraction of that circle, and the fraction of the circle was 60 out of 360. So then you would multiply 8 times 60, divide by 360, and reduce that fraction, and you would find out that it was 4/3 pi. Well, this is called an arc length. And I'm actually going to give you another way of doing this same problem, except in radians. We're going to call the arc length S, and S is going to equal the radius times the angle between the two radii, except that angle needs to be in radians. Now, for this particular problem, we just learned in the previous section, or previous video, that 60 pi is the same as 1 pi over 3 radians. So if I use this formula, the arc length would be the radius 4 times theta, which is pi over 3. And hey, look, I get 4 pi over 3. Now, usually for arc length, we're going to multiply this out. So I would do 4 times pi divided by 3 and actually get approximately 4.19, whatever the units of measurement are. So if I call this centimeters, then this would be centimeters. But instead of finding what fraction of the circumference I was using, I'm instead going to find the arc length by plugging in theta in terms of radians. So let's try this formula again. In example 3, given a central angle of 125 degrees, find the length of its intercepted arc in a circle of radius 7 centimeters, round to the nearest tenth. The way this formula works is you need to know two things. You need to know the radius, and you need to know the angle in radians. So we're going to change 125 degrees by multiplying by 180, or pi over 180. Remember that when we multiply these together, we get 125 pi over 180. And then you're going to reduce 125 over 180 in your calculator and get 25 pi over 36. So now you're going to multiply 7 times 25 pi over 36, and you're going to get approximately, rounded to the nearest tenth, 15.3 centimeters. Let's do this again with an application problem. The Swiss have long been highly regarded as makers of fine watches. The central angle formed by the hands of a watch on 12 and 5 is 150 degrees. The radius of the minute hand is 3/4 of a centimeter. Find the distance traversed by the end of the minute hand from 12 to 5 to the nearest hundredth of a centimeter. So in order to find the distance that the minute hand travels, is asking you to find the arc length. So if you think about this, here's a watch, and here would be the, the big hour hand, or the minute hand, and then there's the small hour hand, and there's your 12. 3 would be here, so look like this. So 4, probably I didn't put 5 in a good place, but like right there. We want to find out how far this minute hand goes from here to here. Now they want you to use the minute hands radius, because that's the one that moves fastest, is 3/4 of a centimeter. And then they also told you the angle here was 150 degrees. But in order to use this formula, we need to change theta into radians. So 150 degrees times pi over 180, which is 150 pi over 180, reduces to 5 pi over 6. Remember, you put into your calculator 150 over 180, you hit math, enter, enter, and it changes into 5 over 6. Don't forget your pi. So the arc length is going to be the radius times 5 pi over 6. When you plug this into your calculator, please use the pi button, not 3.14 like you were told to do in geometry, because we want the most exact answer possible. And you should get approximately 1.96 centimeters. Remember, we're talking about a watch, and the face of a watch can often be very small. In geometry, we also studied area of a circle. And the area of a circle is pi times the radius squared. In order to find the area of a fraction of the circle, called a sector, you would start by finding the area of the circle, and then you would multiply it by the fraction of the circle that you're dealing with. Now, the fraction of the circle is always the central angle divided by 360. So in this particular case, you would multiply 16 pi times 60 over 360, and you would get an answer that reduces to 8 pi over 3 square units. I'm going to show you another formula that uses the central angle in radians and will result in the same answer. In radians, the formula we have for area of a sector is 1/2 the square of the radius times the angle in radians. The biggest thing that students make mistakes on in these problems for arc length and area of a sector is they forget that theta has to be in radians. So first you would change, oops, that's not what I want to do. First you want to change 60 degrees into radians, and 60 pi over 180 reduces to 1 over 3 pi. And then the area is going to be 1/2 the square of the radius times the angle in radians. So 4 squared is 16. 16 divided by 2 is 8. And then you get 8 times pi over 3, which is 8 pi over 3. And I get the same answer. Be careful when doing these area of a sector and arc length problems, because if they give you an angle in degrees, you need to change it to radians. If they give you an angle in radians, then you can just go plug it into the formula as is. So we're going to find the area of a sector if the central angle measures 3 pi over 7 radians and the radius is 11 centimeters and round to the nearest tenth. So the area of the sector is going to be 1/2 radius squared times the angle in radian measure. Hey, look, they gave me the angle in radian measure, so all I have to do is plug it into my calculator. Again, one of the other things that students make a mistake on in this particular formula is they often forget to square the radius. Don't forget to square the radius. When we do area of a circle, we square the radius. And this answer, rounded to the nearest tenth, is going to be 81.5 centimeters squared, because it's an area problem. Example 6, let's do an application problem. In the universe, the most common elements are hydrogen at 73.9%, helium at 24%, oxygen's only at 1.07%, and all the other elements combined are at 1.03%. On a circle graph with a radius of 1 inch, what area of the circle should represent hydrogen, round to the nearest tenth? So we're using the area formula, and we just want to focus on hydrogen. Well, in my circle graph, hydrogen is only 73.9% of that circle. Well, a circle's 360 degrees. So in order to find my central angle, I'm going to have to find out what 73.9% of 360 degrees is. Remember, you multiply by 0.739, and 0.739 times 360 is 266.04 degrees. So now I have my angle, and I have my radius, which is 1. So the area is going to be 1/2 of the radius squared times the angle in radians. Sometimes an easy way to deal with changing degrees to radians is to just tack on the pi over 180. Although you are more than welcome to just do 266.04 times pi over 180. Because you're dealing with something in decimals, I would probably write down an answer in decimals. So 266.04 times pi over 180 is going to give you, it's going to give you about 4.64 radians. So then when you go find the area, you're going to get the answer as approximately, and since we're rounding to the nearest tenth, we're going to say 2.3 centimeters squared is the area of the circle that will take up hydrogen. And that is angles and radian measure part 2.